Chapter 2, Exercise 26. Consider the following sets. A is equal to the set containing 3 and 4. B is equal to the set containing 4 and 3, union with the empty set. C is equal to the set containing 4 and 3, union with the set containing the empty set. D is the set of x such that x squared minus 7x plus 12 is equal to 0. E is the set containing the empty set 3 and 4. F is a set containing 4, 4, and 3. And G is the set containing 4, the empty set, and 3. For each pair of sets, e.g. A and E, specify whether or not the sets are equal. So there's a couple ways you can do this. Now, we can painstakingly go ahead and check every single pair. I invite you to try that on your own if you have the time and motivation to do such a thing. I think that there's better ways because you'd have to check every pair out of 7 elements, which is 7 choose 2, which should be 7 times 6, like 21 or something, which sounds horrible. So let's do something. Let's establish a couple rules for equality, and then we'll use that to reduce these sets to a common form, if you will. So let's call them rules for set equality. So recall that sets are defined to be equal. So A is equal to B if and only if A is a subset of B and B is a subset of A. Now, what this tells us is that we have quite a bit of leniency in terms of what sets we call equal. For instance, sets with repeated elements, so the set 1, 2, 1 is equal to the set 1, 2. Because if you go through each one of these elements and check whether it's in here, then you find that this set is a subset, the left set is a subset of the right set. Whereas if you take each one of these elements and find its corresponding entry here, you'll also find that the right set is a subset of the left set. So that gives us our first rule. And I'm not going to prove them. I think the book itself proves them. And if not, then I believe that they are pretty, if not self-evident, at least easy to work out. So let's call the first rule A, which is repeated entries. And our rule would be if a set A contains repeated, or rather the same element multiple times, we can find an equal set with no repeated elements. So what this is saying is that if we have a set, something like A is equal to 1, 1, 1, 1, then we can map it to a set A prime, which is equal to just the set containing 1. So that'll be our first rewriting rule, if you will, to make these sets a little bit more manageable to work with. Then our second thing will be order, or rather, let's call them unordered sets are equal. This should also hopefully be to not that'll be too confusing. So if a set, or rather, let's say we can arrange the elements within a set A in any order, and the set will still be the same. So if we have something like A is equal to 4, 3, 1, 2, then we can find a corresponding set A prime, call it 1, 2, 3, 4, and it goes without saying that A is equal to A prime here as well. So what we're saying now is that if we find repeated entries, then we can just eliminate the repeated entries, and if we find unordered sets, then we can just order them. And the third rule that we're going to do is uh, let's call it I actually should have thought this through. Largest set possible. I don't know. This is pretty bad, but if A is equal to B union C, then we will express A as the set containing all the elements of B and C. So if A equals B union C, where B is equal to 1, 2, and 1 second. And C is equal to 3, 4, then A is just equal to 1, 2, 3, 4. So we just kind of lump everything together and call it a day. Okay, let me start a new page. So just keep these in mind because my strategy now is just use these rules to express all the sets in a single uniform way and then just see which ones are the same. So let's start with A. A is just equal to 3, 4. And for now, we're just going to say that this is going to map to A prime, which is equal to 3, 4 as well. So it just goes without saying that A is equal to A prime, B is equal to B prime for whatever prime we do. Um, so yeah, my idea is to just order the numbers in increasing order and eliminate all the repeated sets and then just like lump everything together whenever possible. Just apply that repeatedly until we get the simplest possible expression for our sets. So B is 4, comma 3, union with the empty set, which we're going to map to B prime. So first note that the empty set has no elements, so we can kind of just get rid of this part. And then we can order 3 and 4 in their usual way, in, in an increasing fashion. That's the word I'm trying to look for. Sound more professional and mathematical. C is 4, comma 3, union, the set containing the empty set. Now, key difference here is that this is going to map to the set that contains the empty set, and 3 and 4. Next, D, we're going to call it, okay, so Let me just see if I got the formula right. Okay. So some basic application of either factoring or the quadratic formula will net you that D is equal to 3, 4, or rather, let's just do this, and then using our rules to express it in the most simple way possible. There's no simpler way than just 3 and 4. Is that right? Yeah, 3 plus 4 is 7. 3 times 4 is 12. Okay, that looks good. Cool. E is the empty set 3 and 4, which there's not much to do with E prime. E prime, we're just going to leave it as it is. And finally, F is going to be, oh wait, no, there's two more. 4, 4, 3, which after eliminating all repeated entries and rearranging, we should get F prime is equal to 3 comma 4. And finally, G is 4 empty set 3, which we're going to map to G prime. So we have two empty sets. We're going to take one out, and then we're going to move things to put it all in order. So we have empty set 3, 4. Cool. So now things have things have become quite a bit more tractable. Notice first that A prime is equal to B prime, which is equal to D prime, which is equal to F prime, and G prime is equal to E prime, which is equal to C prime. And if you look at any other pair, then you find that they don't have the same elements, and thus immediately you can roll them out for being uh, not being equal. So let's just say that A prime is equal to, what was it, B prime, which is equal to D prime, which is equal to F prime. And this is, since we found that A prime is equal to A, B prime is equal to B, and blah, 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 so on and so forth. A is equal to B is equal to D is equal to F. Same thing. And then by extension of that same logic, we have that C prime is equal to E prime is equal to G prime, which is if and only if C is equal to G is equal to C is equal to E, which is equal to G. Cool. And then any other pair of sets is not equal. Note that when I say pair of sets, here we have four sets put together, but any two of these sets are equal, is all I'm saying, and then any two of these three sets are equal. And then if you take something like A and E, that's not going to be equal, B and C is not going to be equal, D and E is not going to be equal, and so on and so forth. But yeah, that's it. This is the start of the review exercises, if I'm not mistaken. So quite a bit more chill than the other exercises that we've been doing so far, but it'll probably pick back up soon. Anywho, hope that this was helpful. I will see you in the next video. Bye bye.